What happens in our industry is that there are points in time when everything changes.
Everything about IT infrastructure is changing.
If you look at what happened between the late 80s and 2005, all the big companies in the server business basically spent all their time and energy trying to build these very, very sophisticated, vertical, solutions-oriented offerings.
A while back in the old days, computing was expensive. Today, what's expensive is everything around it.
All the people who've invested in all this stuff have an investment that has less value today, and the new companies that have come along have this great value.
It's amazing how little the large companies like IBM and HP and others do when it comes to reinventing computer architecture.
I think what history has proven in the technology sector is that if you don't continue to reinvent yourself and ride the disruption waves, you're going to become obsolete, and those companies go to the graveyard.
There's a very, very big demands for reduced energy.
Power consumption has become a major cost element of computing.
And there's very, very big demand to, if I can use the expression, Googleize, meaning take the cost out of the equipment.
We used to think of servers as stateless. We used to think of servers as a place where you run your compute, and then 5 hops away, you have this box that really persists your data. That paradigm is up for a real upheaval in some sense.
In the last 10, 15 years, it's really shifted towards efficiency, being more agile, and giving companies the ability to change their business processes, their momentum, much more quickly than before.
The big major trend that's caused some of these shifts is virtualization.
Virtualization is not a brand new concept. Server virtualization has basically said we're going to take the excess capacity out of the system. So before server virtualization, it was very common to have a server running at 10% of its capacity.
Virtualization is that one workload that will cover 95% of the data center. It's the vehicle for cloud computing.
As we virtualized the server aspect, we've also created a lot of demands on the rest of the infrastructure in the data center.
Virtualization was really a big paradigm shift because now we could run many dozens of servers on a single physical server.
This comes with a lot of cost and complexity. So now what we're doing is bringing innovations through our technology, but also through our partners like Nutanix to simplify the cost and complexity of the storage layer inside the data center.
All the legacy technology, all those proprietary hardware systems that we have in our data centers, they're all going away, and they're all going to be replaced by commodity, off-the-shelf x86 servers.
The days of the supercomputer, what I call the scale-up architecture, where you keep piling on disk and CPU and drives into a single box to make it better, those days are over.
If you want to crunch on large amounts of data, and you want to make it scalable, you have to do something different that SAN and NAS do not provide you.
They're shifting now to more of a scale-out architecture, where you're taking relatively inexpensive, small, cheaper blocks, you're networking them together. You can actually get significantly improved performance and scaling and density by networking lower-cost blocks than you can with pumping stuff into big iron.
And Nutanix is the only scale-out solution out there in the market.
In some applications, it probably still makes sense. But in most of the new applications, the rapidly growing segment of the market, a converged architecture is definitely the right way to go.
As companies have virtualized more and more important workloads, more mission-critical applications, more performance-intensive applications, the demand to put compute and storage next to each other, to eliminate latencies, to do what many people call data localization, has become a big imperative. And that's where we're seeing very rapid adoption of converged systems, systems that bring the compute and storage right next to each other.
The public cloud infrastructures, because they're at the leading edge of thinking in terms of technology and in terms of their infrastructures in particular, have really started to significantly influence enterprises. If we start and think about this and recognize that they have scale requirements that are incredible in nature, and yet at the same time have the same requirements that any large or small enterprise might have in terms of the requirements to be cost efficient as possible, to be as agile as possible as well. So what's happened in classic Gartner terms is these cloud providers are what we would call type A companies. They're the leading edge of the technology innovation curve. And then the enterprises, which are typically type B companies and type C companies, are now able to leverage off of that knowledge that's been gained from these public cloud providers. And in fact, these efficiencies, to give you some sense of this, is 1 to 2+ orders of magnitude more efficient on a per dollar spent basis for the public cloud providers than it is for a typical IT enterprise as it exists today. Scale-out architectures are a fundamental shift in the way in which technology is being provided today. If we look at the history of technology, we start by understanding that it was very monolithic to begin with when we had mainframes. We migrated over time to client-server computing, where we distributed some of the computing out, but it in fact was still very monolithic then. From there we went to web-based infrastructures where we'd have a 3-tier applications, but instead we still had tiers in place. By having a true distributed computing environment, we now have a peer-to-peer network rather than a true tiering of the environment. This creates a tremendous requirement for the infrastructure to be able to scale. It creates that requirement for having the distributed software to be able to scale. And in doing so, it creates an environment that in fact is driving down our operating costs, driving down our capital expenditures, and supporting the future requirements of the businesses that we're going to need. And by having a distributed scale-out architecture, a distributed scale-out software stack, we're now able to make these changes much more efficiently, be much more agile. And then the infrastructure underneath that to support that is going to be necessary as well, because that infrastructure has to be agile, and that infrastructure has to be able to scale incrementally. It has to be able to be added as needed, rather than making massive capital investments up front and hope that the actual demand gets there. If we have an incremental and linear approach, we can ensure that the resource is always sufficiently used, and adding it becomes very easy because the distributed infrastructure is there to support adding things in a linear fashion. The legacy environment is fundamentally inappropriate. This is especially true for SANs. SANs are the most expensive storage to buy, the most expensive storage to implement, the most expensive storage to maintain. So there's a fundamental shift here from a technology perspective away from SAN-based technologies to these distributed environments. In addition to that, when we start to understand what these distributed cloud storage environments actually look like, we start to recognize that they are in fact scale-out architectures that required intelligence being embedded across the environment. Whereas in traditional storage area network technologies today, the intelligence is exclusively largely embedded in the array. So the technologies and the architectures for storage today that most enterprises are implementing are actually fundamentally inappropriate, both from a cost perspective, from an administration perspective, and then from an architectural perspective, because it's not built to this scale-out architecture where we want to distribute the scale-out knowledge or intelligence throughout the environment rather than having embedded in these single monolithic devices. And in fact, what you'll see largely in the storage environment, we believe, is that that SAN architecture is going to be left behind as clients migrate increasingly to these cloud-based architectures.
What has happened in the last 3 years is really consolidation 2.0. I think the fact that we keep talking about convergence I think that idea of convergence is really consolidation 2.0. It's not just consolidating application servers together, it's consolidating application servers with storage servers, with load balancers, with firewalls, with WAN optimizers, with all sorts of data center services will converge, i.e. consolidating.
So Google pioneered distributed storage with the Google file system. So I was attracted to Nutanix because it was taking this technology that Google pioneered and applying it to enterprise infrastructure. That is, it's attacking a whole new market with virtualization.
The idea is how to bring more agility to IT. We used to do projects in 9 months. Can we do the same projects in 9 weeks if possible? Agility you can never argue against. Time to value, speed to market, ease of use, simplicity, these are things that you cannot argue against. Everybody wants it. I want it for my smartphone. I'm sure people want it for the data center, right?
Nutanix is the first real change in architecture I've seen in 25 years. But more fundamentally, what we invest in is teams. And Nutanix is a team with a real culture of innovation.
I met Nutanix and was really taken with the idea of building a converged system.
I believe Nutanix is a disruptive architecture. I think it will have a large impact in the marketplace.
That is true success. When we can go and be seamlessly accepted by the late majority and the laggards is where you know that this is nirvana in terms of having really built an industry.
Nutanix is white hot right now. They are doing great. And that, notwithstanding all the things that we say and talk about and all the, the goodies, the proof is in the pudding.
A virtual computing platform is a data center infrastructure platform that is defined by 5 characteristics. It's bringing different tiers of the data center infrastructure together, such as compute and storage, and delivering that as one integrated appliance or platform.
And on the same hardware, you can run your web server, your mail server, your firewall. These are typically run on separate hardware. And the reason they can be converged onto Nutanix is what the Nutanix software provides.
All major functions in the data center can be and ought to be managed through software.
If you have intelligent software to abstract and automate and orchestrate, you don't need armies of people to really go and stack up servers and storage and infrastructure. I think this is the next big storage revolution around Flash, and not just Flash on anywhere and everywhere, but Flash on the server side. It makes it really interesting to talk about low latency applications and applications that can really leverage server-side Flash in a way that never has been thought about before.
As your cluster is growing, the data is being spread across a larger and larger cluster, and that gives you seamless scalability. So you can start off small today and add more workload to your cluster, and now you see you need more hardware. Then you add more hardware and it's going to seamlessly grow.
You can deploy that infrastructure in your environment on premises, but it also enables you to easily consume services through the cloud. Those 5 characteristics define a virtual computing platform, and it's really the only way that enterprises should be building their data centers of the future.
Hypervisors allow multiple virtual machines to run on a single physical host and mediate all I/O operations, including read and write requests. A centralized storage array, such as a SAN or NAS, is typically used to provide shared storage for all of the VMs. Nutanix takes a different, much simpler approach. Its converged architecture incorporates local direct attached storage for faster performance and greater flexibility. Each node in a Nutanix cluster includes flash-based storage to deliver massive IOPS for high performance, as well as hard disk drives for low-cost, high-capacity storage. Adhering to the principles of a software-defined solution, Nutanix implements all control logic as a software-based service. A virtual storage controller runs on each node in the cluster, improving scalability and resilience while preventing performance bottlenecks. With storage and control logic now local to the guest VMs, there's no more need for expensive centralized storage or dedicated storage networks. The Nutanix distributed file system aggregates local storage across all nodes, creating a single storage pool that can be partitioned into one or more data stores. These data stores are then presented to the hypervisor, using the standard NFS protocol to provide storage for all hosted VMs. Because the hypervisor communicates to the Nutanix software exactly as it would a traditional storage array, there is zero change to the virtual environment. VMs are provisioned and managed as before, but without having to configure LUNs, volumes, or RAID groups. Now let's look at how Nutanix manages a typical write operation. When a guest VM needs to write data, its request is passed to the Nutanix controller, which then executes the write to local flash storage. It's also important to fully protect data so that it is always available, even if a node fails. To ensure the strongest protection, data is replicated synchronously across multiple nodes. For a typical read operation, requests are served by local storage resources. Keeping data local to the VM provides the fastest possible performance. That means for the majority of read requests, data never traverses the network. With many enterprise workloads, the older the data, the less frequently it is requested. When data becomes cold over time, it is migrated from flash memory to more economical hard disk storage. However, if that cold data at any point becomes hot again, meaning it is requested more frequently by a VM, Nutanix automatically promotes the data back into flash for the fastest possible performance. What happens if there is a node failure? Nutanix supports standard high availability capabilities, such as VMware's HA, so a VM will automatically start on another node. If that VM then needs to read or write data, it sends its request to the local Nutanix controller. If the data being read is not local, the controller determines where replica data has been placed and forwards the request to the correct Nutanix controller. The data is then sent back to the local Nutanix controller over a standard Ethernet network. The local Nutanix controller passes the data to the VM through the hypervisor and stores it locally for future access. At the same time, the Nutanix software once again replicates the data throughout the cluster in order to return the full cluster system to a fault-tolerant state. Each Nutanix node runs independently and leverages the Nutanix distributed software architecture to create a completely unified cluster. The Nutanix virtual computing platform integrates as many as 4 independent nodes into a space-efficient 2U appliance. For more overall cluster capacity, nodes can be added seamlessly one at a time with zero downtime. With Nutanix, you can start small and easily expand to achieve truly massive scale. It's perfect for nearly any virtual workload, including virtual desktops and end-user computing deployments, private cloud projects, big data applications, DR initiatives, and more. Nutanix, the virtual computing platform for software-defined data centers.
The company's growth is spectacular right now. That is the proof of success of an idea.
You know, almost 15 months ago, I'm not even sure if we knew too much about Nutanix.
There's an awful lot of buzz out there, which is great. I think there is all kinds of possibilities.
And now we're seeing them all over the place in our customer base, in our channel base.
If you're looking for the future, if you really want to architect for the next generation, try Nutanix.
We're hearing really positive things about the company and the technology.
By offering Nutanix to our business and being able to drop the cost per unit of virtualization, We're actually able to significantly save money over Amazon and over some of the public cloud providers.
We have an amazing team of employees that are very dedicated to building the best-in-class data center infrastructure product in the world, and we're very committed to our customer success.
The fact that everybody believes that they want to build a Nutanix killer is what makes me really proud. And that is really empowering, and it's very fulfilling and accomplishing as well.
It's our determination, our passion that's in that box, and that's really what makes it special.
We have a sort of a unique, perfect storm of a really difficult technology that not many people can duplicate, that we've managed to master.
Bringing all these different functionality features into a single coherent system is a very difficult problem, but it's a lot of fun.
I'm proud to work for Nutanix because I have a chance to make history.
Everybody around us feels that we are building a game changer. We're building an industry maker.